What is probability? What is probability? Probability is the science of decision making. Science of decision making in the face of calculated risks of uncertainty. Understand? This definition was given by Linchu. Scientist. Probability is the science of decision making in face of calculated risks of uncertainty. Now discuss about probability. What is probability? Before we go into probability, we have known about two words: deterministic, probabilistic. Probabilistic. What is deterministic? What is deterministic? The event has occurred surely. That means if you toss a coin, either of the head or tail occurs. If you throw a die, the number must and should be less than 0. Those are deterministic conditions. If we roll a die, the number on the face of die is less than 7. This is deterministic condition or not? Because every number in the die should be less than 7. Yes or no? If we throw die in n times, we get the number less than 7. So this is deterministic condition. Deterministic means we get exact event, 100% sure. You know that pressure is inversely proportional to volume. Yes or no? Pressure is inversely proportional to volume. Now we have written that PV equals to constant. Yes or no? This is also deterministic because constant does not change. Yes or no? Understand or not? This is deterministic condition. Now we have talked about probabilistic condition. What is probabilistic condition? If we toss a coin, then either of the two outcomes occur. One is head and another one is tail. We do not predict if either head occurs or tail occurs. Yes or no? We do not certain about the events, either the tail occurs or head occurs. That condition is called probabilistic condition. Yes or no? In the deck of cards, we draw 3 cards, and we cannot determine which of those 52 cards the 3 cards are. We cannot determine either king or ace or 1 or 2, 3, 4, 5, 6, 7, 8, 9. Out of 13 cards, those 3 cards are any one of the 13 cards, but we cannot determine exact. Yes or no? Those conditions are called probabilistic condition. Just we assume, but we cannot determine perfectly. Those conditions are called probabilistic conditions. Understand? This is the difference between deterministic and probabilistic. Here deterministic means we exactly find out what the event occurs. Here probabilistic means we cannot exactly find what the event occurs, but we guess. This is the difference between deterministic and probabilistic. Now, what is random experiment? Random experiment means it is a type of experiment. We can repeat it under certain identical conditions. Okay, the experiment is repeated under certain identical conditions. The possible outcomes of a experiment are known in advance, but the actual outcome of a experiment is not known in advance. Suppose we toss a coin. Tossing a coin is a random experiment. What are the possible outcomes? Head or tail. We know the possible outcomes of an experiment, either head or tail, but we do not know the exact what either head or tail. This experiment is called random experiment. Okay, random means if we repeat the experiment under certain conditions. If we toss a coin 4 times or toss a coin 10 times, this is random experiment. In identical conditions, we repeat those experiments. Yes or no? The experiment which is repeated under identical conditions. The possible outcomes of an experiment are known in advance. But the actual outcome of an experiment is not known in advance. These type of experiments are called random experiments. Example, tossing a coin, rolling a die, tossing 2 coins or tossing 3 coins, rolling 2 dice, rolling 4 dice. What are the examples of random experiment? Tossing a coin, rolling a die, we repeat the experiment in identical condition. If you first toss a 1 coin, then second time also we toss 1 coin. Otherwise, if we toss 2 coins in second chance, it is not a random experiment. These are the examples of random experiment. Next, outcome. What is outcome? The result of an experiment is called outcome. If you are rolling a die, what are the possible outcomes? Rolling a die, we get possible outcomes 1, 2, 3, 4, 5, 6. Either of these numbers occurs. Yes, this is outcome. The result of an experiment is known as outcome. Next, event. Any particular performance of an experiment. Any particular performance of an experiment is called event. Let we throw a die. The event of getting even number of first throw is the one event. Let E to be the event of getting odd number on the second throw is the event. Yes or no? Any particular performance. Here we throw the die once. Any particular performance of exponent is called event. Suppose we toss a coin. Suppose we toss a coin. The event of getting head on first pair. So now, this is the event. Here, what is the event? Getting head on the first trail is the event. Next, what is second event? Getting tail on the second trail is the event. Next, what is third event? Resume that event. Yes or no? If you rolling a die, resume that getting a multiple of 2 in the first throw, multiple of 4 in the second throw, multiple of 6 in the third throw, even numbers on fourth throw, prime numbers on sixth throw. These are the events. Those are the particular performances which we repeated in a random experiment. Those are known as events. Understand? Sample space. What is sample space? The collection of all possible events is known as sample space. The collection of all possible events is known as sample space. In the deck of cards, what is the sample space? There are 52 cards in the deck of pack. 52 cards are the sample space of deck of cards. In rolling a die, what is the sample space? 1, 2, 3, 4, 5, 6. In rolling 2 dice, what is the sample space? 36. There are 36 elements in the sample space. 1, 1, 1, 2, 1, 3, up to so on 6 to 6. Understand Nana? Sample space means the collection of all possible events. All possible events is known as sample space. So it is denoted by sigma RS. Example. If you toss 2 coins, what is the sample space? Head, head, tail, head, tail head. This is the possible sample space of tossing 2 coins. Understand? If the family has 3 children, what is the possibility is that the first girl is child? Suppose the family has 2 children. Either the 2 children are girl, girl, boy, boy, girl, boy, boy. Now, what is the probability that the first girl, the first child is girl? First child is girl means this is first child. This is one of the possible outcomes. This is also one of the possible outcomes. The possible outcomes are 2. Total number outcomes are 4. Understand? These type of questions are asked. Understand? Random experiment, event, sample space. What is mutually exclusive events? Mutually exclusive events. Mutually exclusive events means The both the events never happen simultaneously. We are tossing a coin, we do not get both head and tail on same time. Yes or no? Either head or tail occurs, but both head or tail not occurs. This is mutually exclusive. Mutually exclusive means both the events cannot occur simultaneously. Understand or not? The events are called mutually exclusive events. Example, tossing a coin, you cannot get both head and tail on same trail. Understand? These events are called mutually exclusive. Both the events cannot happen simultaneously. Mutually exhaustive events. Mutually exhaustive means the possible outcomes of an experiment are called mutually exhaustive. The set of all possible outcomes of a random experiment are called mutually exhaustive events. In rolling a die, what are the mutually exhaustive events? We are rolling a die. What are the mutually exhaustive events? 1, 2, 3, 4, 5, 6. Understand? Next one. Equally likely events. Equally likely events means the probability of occurrence of each event must be equal. Then those events are said to be equally likely events. The events having same probability of occurrence is called equally likely events. Understand? We are tossing a coin. We have head and tail are two events. What is the probability of getting head? 1/2. What is the probability of getting tail? 1/2. So both the probability of getting head and tail are equal. So those two events are said to be equally likely events. In a rolling a die, what is the probability of getting 1/6? What is the probability of getting 2? 1/6. What is the probability of getting 3? 1/6. Yes or no? The probability of getting each number of the die must be equals to 1 by 6. So those events are called mutually exclusive, sorry, equally likely events. Equally likely means they have same probability. Suppose probability of getting even number on a die must be equals to 1 by 2. Probability of getting multiples of 3, multiples of 3, 1 by 3. These two are not equally likely because the probability of getting even number is 1 by 2. The probability of getting multiple of 6 or 3 is 1 by 3. So here probability of occurrence must be different. Here 1 by 2 or 1 by 3. These are not equal. So these two events are not equally likely events. So no. The events are said to be equally likely. They have same probability of occurrence. They have same chances. In the basket there are 10 balls. Out of 5 red, 5 black. Now drawing 2 balls. They have same probability. So no, because they have 5 balls, 5 black and 5 red. Each having a same probability. Yes or no? Drawing a red ball is 1 by 10. Drawing a one black ball is also 1 by 10. No, not 1 by 10. 5 by 10, 5 by 10. 1 by 2. Because there are 10 balls in the basket. Out of 5 are red, 5 are black. What is the probability of drawing a red ball? There are 5 balls. Possible outcomes are 5. By total number of outcomes are 10. 5 by 10, 1 by 2. Drawing a black ball. 5 by 10, 1 by 2. Those two events are equally likely. Sir, no? Understand? Independent events. What are independent events? If the two events are said to be independent, if the happening of one event does not affect the happening of other event. This is the definition of independent events. Clear? A coin is tossed 2 times. And the first time, the event of getting it is independent of the possibilities of getting tail in the second toss. If you get the tail in the second toss is independent of get in the first toss. Yes or no? Not answer. If we toss a coin 2 times, in the first try we have possibility that getting head. In the second try we have possibility that getting tail. These are independent because the probability that getting head is not dependent on probability of getting tail in the second toss. Yes or no? There is no independence between head and tail. Understand? This is the independent events. The two events must be independent. One event does not depend on the second event. Yes or no? Independent means does not depend on others. If you pass the 10th class examination, then you will go to intermediate. Otherwise, you cannot go to intermediate. This is the dependent. If we pass MSET, then we will go to engineering. Otherwise also we will go to engineering. Those are not dependent. If we pass, then dependent. If we do not pass, independent. These are independent events. Next one. What is the definition of probability? Classical definition of probability. What is the classical definition of probability? If there are n mutually exclusive and exclusive exhaustive and equally likely events, out of those m events are favorable for occurrence of an event, then probability of event is given by m by m. This is the classical definition of probability. There are n mutually exclusive, exhaustive and equally likely events. Out of those, m events are favorable for occurrence of an event. Then probability of that event is given by probability of event equals to m by n. M means the favorable cases for occurrence of an event. N means total number of possible outcomes. Understand? This is the classical definition of probability. We apply classical definition of probability when the events are mutually exclusive, exhaustive and equally likely. If any of those three conditions are failed, then we cannot apply classical definition of probability. If we only apply classical definition of probability when the events are mutually exclusive, exhaustive and equally likely. Otherwise, we cannot apply classical definition of probability. We will go to empirical definition of probability. Understand? Tossing a coin 3 times. What is the probability of getting 2 heads? Now, tossing 3 coins. What is the sample space for tossing 3 coins? What is the sample space for tossing 3 coins? 2 cube. There are 8 possible outcomes. Because if we toss n coins, then the sample space is 2 power n. Here we toss 3 coins. So, sample space is 2 cube 8. Now, what is the possible sample space? Second coin head, third coin head. First coin head, second coin tail, third coin head, tail, head, tail, tail, head, tail, 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 head, tail, tail, head.
అక్కడ 2 టైమ్స్ రాశారు.
Head to tail, tail. Next. Tail, tail, tail. Tail, tail, head. Tail, head, tail. Tail, head, tail. What is the probability of getting 2 heads? Here 2 heads, here 2 heads, here 2 heads. Total possible outcomes are 3.
3
By total possible outcomes are 8. Understand now?